This is the second section in the polar coordinates chapter, and this is sketching curves. Now there's a few that we should try and remember. So if we have r equals a is a constant, what you get is a circle centered on the origin with a radius of a. So we will get something like this. This is meant to be a circle, folks. Okay, and the radius of this is a. So radius equals a. So I'll be crossing like a on that axis and negative a on there and so on. Okay, the next type is where we have theta equals alpha. So it equals a particular angle. Now this is a half line. Now we've come across half lines before with complex numbers and Argand diagrams, and it's a half line that starts at the origin and it makes an angle of alpha with the initial line. So here's an example. So my half line will be going like that. Yeah, and this angle here would be the angle alpha. Okay, so it starts at the origin and it makes its way out from the origin. The next type is r equals a theta. Now I said in the last video you can think of r like the radius, and what's happening here is as theta increases, then the radius increases. So what we're going to have is basically a spiral. So we start at the origin, and as we move around from the origin, what happens is that the radius is getting bigger, and as the radius gets bigger, we end up with a spiral like this. Okay, so we have circles here, half lines, spirals. Now we can also use our calculators to help us sketch these, and you would need the FX CG50 calculator, okay, which is like a new modern color screen calculator which you can use to sketch graphs. And if you're going to use that, then you start by pressing menu, just like you do on the other simple calculator, and graph is number 5. It's actually a picture of a graph. It's nice, it's got a color screen. And then once you've pressed number 5, you need to select type, which is F3. Got your function buttons along the top, and then you select the second one by pressing F2. So this is type here, and when you press F2, it selects polar equations. You'll see it says r equals, yeah, so you press that one, then it will say like r1, r2, r3 along the side. If you press the go to whichever equation where you want to type it in, then you press the right cursor. So you do the right cursor here, and then it'll let you enter it. And anytime you want to enter theta, you press the button that says x theta t. That allows you to enter your parameter. Okay, so press to enter theta. Now when you draw your graph, it may be that it comes up too small, you can't see it, or well, first of all, once you've typed it in, if you press F6 to draw, so F6 will draw it for you once you've typed it in. And then you may find when you draw it, you only get a part of the graph on the screen. You can resize the window. Now the easiest way to do it, if you press, so to resize, if you press F2, and it says like zoom above it, and then press F5, which is auto. It will automatically resize the screen for you, but it may be that your scales are not balanced. So something that should be a circle ends up like an oval. So you just need to be careful of that, check the axes. So you might want to rescale the axes so that they're both on the same scale, so you get like a proper representation of the shape. Okay, so we've been asked to sketch each of the following curves. So here's my initial line here. Suppose we should write it on initial line. And these here represent angles. 0, pi over 2, pi, 3 pi over 2. And r is 5, so that's just a circle with a radius of 5. So all of these numbers here are going to be 5, yeah, because r represents the distance from the pole. Part B, okay, this is going to be a half line with an angle of 3 pi over 4. So that is 135 degrees, so it looks like this. Okay, and that line goes on forever. And then this angle here, measured from that way, is 3 pi over 4. And the last one, C, this is just a spiral. So there's our initial line. There is our angles, pi over 2, 3 pi over 2, and we just draw a spiral spinning out of control like that. And these values where it crosses the axis, it's just going to be whatever the angle is times by a. So that angle there at the top is just going to be a times pi over 2, so it's going to be pi over 2a. This bit here, the angle is pi times by a, so that's a pi or pi a. This one down here, that will be 3 pi over 2a. And then when we get to here, this will be 2 pi a. Yeah, so basically that distance r is a times by the angle. Okay, so we're going to sketch the following curves. We're going to use tables to help us. We can use our calculators, but you do need to be aware your calculator may plot for negative values of r, which we don't want. So it may be worth making a point here that we don't want r to be negative, yeah, because you can't really have a negative length as such, so we don't want r to be negative. So when we do our tables, we are going to ignore any values where r is negative, and we won't plot those. Yeah, we'll just leave those out. And the second thing is, if we have things like cos theta or sine theta, then we want to go up in pi over 2's when we draw our tables. If I have cos 2 theta or sine 2 theta, I want to halve that, so I want to go up in pi over 4's. If I have cos 3 theta, sine 4 theta, sorry, not 4, 3 theta, then I will go up in pi over 6's. Okay, so for whatever number you have there, that will be determine how much you want to go up in. So I suppose we could generalize that and say if you're going up, if you're plotting cos n theta or sine n theta, then we want to go up in pi over 2n. Yeah, pi over 2n. That's what we want to go up in our table. So let's start with part A. So since this is theta, we're going to go up in pi over 2, so we'll go 0, pi over 2, pi, 3 pi over 2, and we want to go up to 2 pi. 2 pi. Yeah, now we're going to work these out. Now if I get any values in the bottom r which are negative, we ignore them. Yeah, so let's work out what these are. So I'm going to get answers in terms of a. So I basically just need to work out what's in a bracket. So if I do 1 plus cos 0, okay, I get 2, so that's going to mean basically 2a. If I do 1 plus cos pi over 2, pi over 2, then I get 1, so that's basically going to be an a. If I do 1 plus cos theta, I get 0, so a times 0 is just 0. Then if I do 1 plus cos 3 pi over 2, that's going to give me 1, so a, and then I work out the last one, 1 plus cos 2 pi, which is 2, so I get 2a. Right, so now I'm going to plot these. Now remember, this is our initial line here. I'll just put IL for initial line. And the lines that we draw round here are angles. So we're starting at 0, a bit like a cast diagram, pi over 2, 3 pi over 2, whoops, no, that's pi, 3 pi over 2 is here, and this will be pi here. Right, so let's plot these points. So when the angle is 0, the length you could think of is 2a. So 2a, so I'll plot a point there. When the angle is pi over 2, the length is a. Okay, so a there. When the angle is pi, the length is 0, so go to there. When the angle is 3 pi over 2, the length is a, so I'm here, and then I'm back to 2a. Now, it takes a bit of practice drawing these, but they're always curved shapes, so what we get is something like this, okay, which is like a heart shape. Right, part B. So in part B, we're going to do the same thing again. We're going to draw a table. Now, we've got 3 theta, so we're going to go up in pi over 6's. Pi over 6, 2 pi over 6, 3 pi over 6. And we want to go up and stop when we do 3 times that, we get 2 pi. So 4 pi over 6. So 4 pi over 6 will be the last one, because 4 pi over 6 times by 3 gives you 2 pi. So again, we're going to fill in the table. Now remember, if we get anything that's negative, for r, we ignore. Okay, so I'm going to do sine of 3 times pi over 6, which is 1 times a, it's going to be a. Now I've just realised that really I should have put a value in for theta is 0. So there we go, like magic, that suddenly appeared. The power of being able to pause the video and change things. So yeah, let's go to and do the first column. So if I do the sine of 0, which is 0 times that by a signed up with 0. Next one, I'm going to do the sine of 3 times 2 pi over 6, 2 pi over 6. So that gives me 0. Times that by a, we get 0. Then I'm going to do the sine of 3 times 3 pi over 6, which is like pi over 2, 3 pi over 6, and that gives me -1, so that gives me -a. So this is going to be one that we ignore, and then sine of 3 times 4 pi over 6, 4 pi over 6, that's going to give me 0. So we ignore this one here, yeah, because we don't have negative values of r. We can have negative angles but not negative values of r. So let's plot this. So we'll just draw our initial line so you don't think it's like an x and a y axis. And yeah, we're just going to put a line in here so we can see where pi over 2 is. So 0, pi over 2, pi over 2, pi, 3 pi over 2. Right, so when the angle is 0, we have 0 length, so that's there. When the angle is pi over 3, so that's what, 30 degrees, the length is a, so probably something like this, a, so that's meant to be like about 30 degrees there. When it's 2 pi over 6, it's back to 0 again. We ignore the 3 pi over 6, and then when it's 4 pi over 6, which is like 2/3 pi, which is like 120 degrees, we're back to 0 again. Now that will give us this. Remember, they're curved round. But remember, as we increase the angles, we're going to get the same thing happen again over here and over here. We didn't go all the way up to 2 pi. We've only done 1/3, so we only get 1/3 of the diagram. So that will be a, and that length will be a. Yeah, and these sort of angles here, well, we'll see we get that nice shape. They're all separated by 120 degrees or 2 pi over 3. And a third one we're going to do, we'll do the table down here. So we've got cos 2 theta. So that means we're going to go up in values of pi over 4. Pi over 4. Whoops, starting from 0. And like before, when we work out r, if there are any negative values for r, we ignore them. 3 pi over 4, 4 pi over 4. Let's just write it like that. So that's like the equivalent of going up to 2 pi, because they're going to get multiplied by 2. So let's now fill in the table. And remember, we need to square root our answers. Yeah, because what we're going to get from the equation is r squared. So don't forget to square root to find r. So here's the table. I worked it out rather than keeping you waiting. You can see we get a negative value there, so that one we ignore. We draw our initial line here, and then we're just going to mark in a line so we can see where our angles are. So 0, pi over 2, pi, 3 pi over 2, and we'll just plot these points. So when we have an angle of 0, we have a length of a, so that will go there. When we have an angle of pi over 4, we're at 0. 3 pi over 4 is 0. And when it's basically pi, it's a, so it's over here. So what's happening is this graph is starting from here, and it's going round like this. Yeah, these are sort of shapes that you'll begin to memorize. Now, if you actually work this out on and draw it on a graphic calculator, this is where you need to be careful. It will give you these bits here as well. So I'll draw them in. It will give you that bit and that bit there, which isn't actually part of the diagram. So do be careful when you've got your graphic calculator that not everything you see is everything that you should plot. So just take care with those. Okay, so there's two other curves here we're going to sketch, and we've got a couple of tips here. We drew one in the last example that was like this one here. Now, how do we know when it's like a dimple, when it's got an egg shape? And that is to do with the relationship between P and Q. These two numbers here. So basically, if our value of P, so in my examples, that one P is 5 and this one P is 3. If P, that number, is greater than or equal to 2 times Q, and in my example, let's write this down, that's P, so that number's Q, and that number's Q. So if it's greater than 2 times Q, we get this egg, there's no dimple. Okay. However, if P is greater than Q, but still less than 2 times Q, so it's greater than Q, and P is less than 2 times Q, that's when we get the dimple. Okay, so I can see from my first one, P, which is 5, is greater than 2 times Q. This is going to give me an egg shape. Then the second one, where P is greater than 2, but it's not 2 times bigger than Q, or 2, then this one will give me a dimple. So now I know the basic shape. What I now need to work out is whereabouts it's crossing the axis, and I can use a table to do that, or I can sort of even just draw the sketch and look at the angles I need to work out. Now, the important places are going to be, as we said before, every pi over 2, because we've got cos theta here. So we are going to do a table, and really only 0, pi over 2, pi, 3 pi over 2. Okay, and 2 pi is going to basically take me back to the start again, so I don't need to worry about that. So we're going to work out these values. These values are going to be in terms of R. So I'm going to work these out. And when I do work them out, the values we get are 7a, 5a, 3a, and 5a again. So we draw our egg, and then we just put those points on the axis. So it's almost like a circle, but it's like squashed at one end. So something like this, it sort of flattens off a bit and then becomes a bit more circular around there. And then we can just put those values in from the table. So 0, so it's my initial line. So remember, this vertical line here is not an axis, it's an angle. Yeah, so 0, pi over 2, 3 pi over 2. Oh, I did that again. 3 pi over 2 is down here. And this is pi over 2, or pi. And then I can just mark these in. So here, that's 7a. Here is 5a. Here is 3a. And here is 5a. So there we go. Yeah, if we can remember the egg and the dimple, it will save us lots of time. So that's part A. Part B, well, we know that's going to be a dimple. So let's do our table so we can get the points basically every 90 degrees. So same thing again, 0, pi over 2, pi, 3 pi over 2, like this. And then I can work out those values by substituting them in. And when I work them out, I'll get values of 5a. So I've worked this out before. 3a, a, 3a. Right, so let's plot our initial line. I know I'm drawing a solid line here, but that line represents an angle. So 0, pi over 2, pi, 3 pi over 2. So this time it has a dimple. So when we draw it, we go around, draw our little dimple like that, and round there. So now we can fill in the values. So 0 angle 5a, pi over 2 angle 3a, pi angle a, 3 pi over 2, 3a. Okay, in part A, it's asking us to show that loci on an Argand diagram. Now hopefully we should remember from core 1 that's a circle. So let's draw that. So we need our axis for an Argand diagram. Let's draw that. Let's write the equation in the correct form so we can find the center. So it's going to be z minus, so that's going to be 3 plus 4i will be the center. So 3 here, 4 here, the center there. Let's draw it on something like that. We know it crosses the axis because of its radius. So we've got center, 3, 4, radius, 5. Right, part B. Show that the locus of points can be represented by this polar curve here. So let's start by writing what the Cartesian equation is. X minus 3 all squared plus y minus 4 all squared equals 25. So the x we can replace with r cos theta minus 3 all squared, and the y we can replace with r sine theta minus 4. So we'll expand the brackets. So we'll have r squared cos squared theta minus 6r cos theta plus 9. Then the second brackets, r squared sine squared theta minus 8r sine theta plus 16 equals 25. Now 9 plus 16 is 25, so we can take away 25 from both sides. Now we're going to factorize it. So we'll have r squared, then in brackets we'll have cos squared theta plus sine squared theta. We'll factorize the r, so I'm going to put minus r because both terms are negative, and that will be 6 cos theta plus 8 sine theta equals 0. I can change this to 1. Also move the bracket to the other side and divide both sides by r as well. Let's do one step at a time. So we'll have r squared equals r 6 cos theta plus 8 sine theta. Then divide both sides by r, and we have r equals 6 sine theta, 6 cos theta, 6 cos theta plus 8 sine theta. So there we go. We've proved it. That circle can be written, or the equation of that circle can be written that form. Right, you should now be able to do exercise 5b on pages 108 and 109. So there is a summary of all of the things that we've looked at, the egg shape, the dimple. So compare that P with Q, see what you notice. Remember, R equals A as a circle, we have that half line, and we have a spiral. But also remember that when we draw these, we have our initial line here. When we draw this, okay, that is an angle. So 0, pi over 2, pi, 3 pi over 2.